Welcome to the peaceful space of sleep-friendly science, where we gently ponder the universe's greatest mysteries, like the soft, persistent arrow of time that points ever toward the future. Have you ever found yourself gazing at the stars, wondering why we can remember yesterday but not tomorrow? This question is tied to a beautiful, universal concept called entropy, the cosmic dance that gently guides everything from a cooling cup of tea to the stars themselves. Always forward. Now, settle in, take a deep breath, and let the soft sounds of the universe guide you as we begin tonight's journey into the unknown. Section 1. The unbroken egg and yesterday's tea. Let your mind drift now to a quiet kitchen, bathed in the soft, early light of a morning that has long since passed. On the counter rests a single, perfect egg. Feel the weight of it in your imagination. Its shell is a smooth, cool dome, a small, seamless world of potential. It is a universe of its own, holding within its fragile walls a perfect separation of yolk and white, a state of quiet, simple order. It is a promise. Now imagine a gentle nudge. The egg rolls just for a moment before it falls. Time itself seems to slow as it arcs through the air. And then, the sound not loud but definite. A sharp, clean crack as it meets the floor. And in that instant, the promise is broken. The perfect, ordered world inside spills out in a beautiful, chaotic splash of gold and translucent white. The shell lies in pieces, a mosaic of what once was. Take a deep breath and think about this simple, mundane tragedy. We have all seen it happen. But have you ever truly considered the magic, the profound and unyielding law that you have just witnessed? You can clean up the mess. You can wipe the floor until it shines. But you can never, ever make the universe put that egg back together. You can never command the scattered yolk and white to retreat, to separate, to pour themselves back into the shell as the fragments fly together and seal their seams into a perfect, unbroken dome once more. Why not? The laws of physics in their purest form don't seem to forbid it. The motions of atoms, if you were to watch them, look just as sensible running backward as they do forward. A planet orbiting a star would look perfectly normal if you reversed the film. Yet, in our world, the film only ever plays in one direction. The broken egg stays broken. The spilled milk never gathers itself back into the pitcher. This is the arrow of time. It is not a grand, celestial signpost hanging in the cosmos, but a quiet, persistent, and unbreakable rule that governs every single moment of your life. It is written in the very fabric of existence, as fundamental as gravity, as present as the air you breathe. Let's leave the kitchen floor and imagine another scene. A warm cup of tea, held in your hands on a cool evening. You can feel its heat radiating, a gentle gift of warmth to your skin. You watch the steam rise from its surface, coiling and dancing in the air. A soft, ephemeral ghost. Each wisp of steam is a tiny cloud of fast-moving water molecules, escaping the collective warmth of the cup and venturing out into the vast, cool expanse of the room. They share their energy, their heat, with the cooler, slower air molecules around them. The dance is beautiful, but it is a dance of giving away. The tea is cooling. The room is, by an infinitesimal, unmeasurable amount, warming up. And you know, with a certainty that needs no scientific proof, that this process will never reverse itself. You will never see the random, scattered water molecules in the air decide, all at once, to gather themselves together, to dive back into the cup, and to give up their energy to make the tea steaming hot once more. It simply doesn't happen. The warmth always flows from hot to cold. The steam always rises and dissipates. The gift of heat is never taken back. Now let's add a drop of cool milk. Watch as it plunges into the amber liquid. For a moment, it holds its form, a stark white cloud. Then it begins to bloom. Tendrils of white curl and swirl through the brown. a silent, graceful ballet of two liquids becoming one. It is a fleeting masterpiece, a unique pattern of chaos that will exist for only a few seconds and will never be repeated in exactly the same way again. Soon the dance is over. The swirls have faded, and the cup now holds a single, uniform, milky brown liquid. It is a new state of being, a new, peaceful equilibrium. And again, the arrow of time holds its steady, unyielding aim. You can stir the tea for an hour, for a day, for 1,000 years, and the milk and tea will never spontaneously unmix. The molecules will never conspire to separate themselves back into the distinct, ordered forms of pure tea and a single, perfect drop of milk. The dance, once finished, is finished forever. This is the great, gentle mystery we are here to explore tonight. It's not a question of complex equations or distant, alien worlds. It is a question that lives in your own home, in your own hands, in your own memories. Why does the vase, once shattered, remain in pieces? Why does the echo of a beautiful song fade into silence, but silence never gathers itself into a song? Why does a building crumble to dust over centuries, but a pile of dust never assembles itself into a building? It is because the universe has a preference. It has a direction. It is flowing, like a vast and silent river, from a state of structured, simple order towards a state of diffuse, uniform, and peaceful chaos. Everything we see, everything we do, everything we are, is simply a momentary pattern, a beautiful temporary eddy in this grand cosmic current. Think of your own memories. They are like photographs of a past that is gone forever. You can remember cracking the egg. You can remember the warmth of the tea. You remember the past because the past was different from the future. It was more ordered. The egg was whole. The tea was hot. The milk was separate. Your brain, itself a part of this universal flow, can only record the journey in one direction from order to disorder. We are travelers on this river of time, and tonight we are not going to fight the current. We are going to drift with it. We are going to let it carry us. And we are going to look at the passing scenery with a sense of wonder, not confusion. The flow of time isn't a cage that traps us. It is the very process that allows for life, for change, for stories to unfold. Without it, nothing would ever happen. The egg would remain forever on the counter, the tea forever hot, the universe a static, frozen portrait. So let that thought settle. The constant, forward march of time isn't a flaw in the system. It is the system itself. It is the heartbeat of the cosmos, the gentle, rhythmic exhalation of the universe as it moves from its compact, fiery beginning towards a long, quiet, and peaceful end. We are living within one of those breaths. As you lie here, feel the warmth of your own body, a temporary island of heat and order. Feel the gentle rise and fall of your chest. Each breath you take is a small act of participating in this cosmic dance. You are a part of this unfolding story, and understanding its direction, its gentle, inexorable flow, is the first step toward finding a deep and profound peace within it. The broken egg is not a tragedy. It is the universe behaving as it must. The cooling tea is not a loss. It is the universe finding its balance. And the forward flow of time is not a mystery to be solved, but a current to be understood, a song to be heard, a dance to be joined. Section 2. The gentle whisper of entropy. The question that hangs in the quiet air of our imaginary kitchen, the question that lingers over the cooling cup of tea, has a name. It is not a loud or demanding name. It is a soft and pervasive sound, a constant, underlying whisper that hums beneath all of reality. Scientists call this whisper entropy, but let us not think of it as a cold, clinical term from a textbook. Let's think of it as the universe's natural inclination to relax. It is the cosmos gently sighing, letting go of tension, and settling into its most comfortable, most probable state. The arrow of time, the reason the egg stays broken, is guided by this profound and gentle tendency. Entropy is the cosmic dance of things moving from a state of unlikely order to a state of peaceful, boundless freedom. Imagine, if you will, a grand ancient library, the library of all possibilities. In this library, there is a single, small room meticulously organized. Every book is in its precise alphabetical place on the shelves. This is a state of very low entropy. It is highly ordered, specific, and there is only one way for it to be perfect. One book out of place and the perfection is broken. This room represents the unbroken egg, the hot cup of tea, the perfectly separated drop of milk. It is a state of low probability. It is special and fragile. Now, imagine the rest of this infinite library. Countless halls and chambers where the books are not in any specific order. They lie on tables, they are stacked in corners, they are left open on chairs. There are billions upon billions of ways for the books to be messy, to be disordered. But there is only one way for them to be perfectly ordered. This vast, disordered state is the state of high entropy. It is not chaos in a negative sense. It is a state of freedom. The books are simply existing in the countless arrangements available to them. The universe, like a librarian who has worked for eons, is not actively trying to make a mess. It is simply that the states we call messy or disordered are overwhelmingly more numerous, more probable, than the one single state we call ordered. And so, with every passing moment, the universe is simply exploring these possibilities. When the egg breaks, it is as if a perfectly stacked tower of books has been gently nudged, and it has fallen into one of the trillions of possible random piles. It is so fantastically unlikely that the random vibrations of the floor would ever conspire to knock that pile of books back into a single, perfectly stacked tower. It's not forbidden. It's just astronomically improbable. Let's try another image. Picture a brand new deck of cards, held in your hands. You open the box, and the cards are in perfect sequence. Spades, hearts, diamonds, clubs, ace to king in each suit. This is a state of perfect order. Low entropy. It is a single, specific arrangement out of countless possibilities. Now you give the deck a shuffle. Just one. A gentle interweaving of the cards. The order is broken. You shuffle again. And again. The cards mix and mingle, surrendering their rigid structure to a state of beautiful randomness. This is entropy increasing. With every shuffle, you are exploring the vast number of ways the 52 cards can be arranged. Do you know how many ways there are? It is a number so vast it beggars belief, an 8 with 67 zeros after it. More possible arrangements than there are atoms in our entire galaxy. So, when your deck is shuffled, it has settled into one of these countless, random, high-entropy states. Now ask yourself, what are the chances that your next shuffle will magically return the deck to its original, perfect, new deck order? The chance is 1 in 80 million billion 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 billion. It is so close to zero as to be functionally impossible. Time does not flow backward for the same reason. The universe is constantly being shuffled. The atoms and energy that make up everything are constantly interacting, mixing, and settling into more probable, more random arrangements. To unscramble the egg is like trying to unshuffle that deck of cards with one perfect, magical move. The universe simply doesn't play the game that way. Its game is one of ever-increasing possibilities. Let this idea settle into your mind like soft dust. Entropy is not a force, like gravity, that pulls or pushes. It is a law of probability, a statement about what is likely to happen. And what is most likely to happen is that things will spread out, mix together, and find a state of equilibrium. Think of a castle made of sand on a vast, empty beach. You have spent an afternoon carefully sculpting it. You have built towers and ramparts, a delicate and intricate structure. You have, for a short time, imposed a beautiful, unlikely order on the random grains of sand. Your castle is an island of low entropy in a sea of high entropy. And then the tide begins to come in. The ocean does not hate your castle. It is not an act of destruction. The waves simply wash over the sand, and the water gently, patiently, lovingly, coaxes each grain of sand to let go of its rigid, improbable position in your tower. The water invites the sand to rejoin the smooth, uniform, and peaceful expanse of the beach. The beach is the sand's natural state. It is its most probable state. There are countless ways for sand to be a flat beach, but very few ways for it to be your specific castle. The tide is the gentle hand of entropy, guiding the system back to its highest probability, its most stable and restful configuration. The arrow of time is the tide that is always coming in. This concept of spreading out is key. Imagine opening a small bottle of perfume in the corner of a quiet room. At first, all the fragrant molecules are trapped in the bottle, a highly concentrated, ordered state. Low entropy. The moment you open it, they begin to drift out. They are not pushed out. They are simply free to move, and they begin a random, gentle dance on the air currents. They spread out, exploring the entire volume of the room, until eventually, the scent is faintly detectable everywhere. They have moved from a state of low probability, all being trapped in one tiny bottle, to a state of high probability, being spread evenly throughout the room. They will never, on their own, decide to all fly back into the bottle. To do so would require trillions of molecules to randomly all move in the exact same direction at the same time and end up in the same tiny space. The universe doesn't work against such staggering odds. It follows the path of least resistance, the path of highest probability. The warmth from your cup of tea spreads into the room. The sound of a bell spreads through the air. The light from a star spreads through the cosmos. Everything is spreading, sharing, and settling. So when we talk about disorder, let's reimagine it. Let's not see it as a mess. Let's see it as simplicity, as freedom. The uniform, milky brown tea is simpler than the complex, separated state of pure tea and a drop of milk. The flat beach is simpler than the intricate castle. The shuffled deck is, in a way, more free than the rigidly ordered one. The universe, in its grand, slow cosmic dance, is moving toward a state of ultimate simplicity and peace. A state of perfect equilibrium where everything is spread out, uniform, and at rest. This is the gentle whisper of entropy. It is the reason for yesterday, today, and tomorrow. It is the silent, invisible current that carries us all forward. It is not a prison, but a process. It is the unfolding of the universe's most likely story. And we, with our ordered bodies and our structured thoughts, are the beautiful temporary sandcastles built on the shore of its cosmic ocean. We are the fleeting, intricate swirls of cream in the universe's cup of tea. A momentary rebellion of beautiful, improbable order, before we too are guided back into the peaceful whole. Section 3. A universe wound like a clock. We have drifted on the gentle current of entropy, understanding now that time's arrow is guided by a universal preference for the probable, for the relaxed, for the states of being that are, for lack of a better word, freer. The broken egg, the cooling tea, the shuffled cards, they all follow this path from a single special state to one of countless common ones. But this raises a deeper, more profound question, one that takes us back to the very beginning of everything. If the universe always moves towards higher entropy, towards a more disordered state, then it must mean that in the past the universe was more ordered. And if you follow that logic all the way back, as far as you can possibly go, you arrive at a staggering conclusion. The universe must have started in a state of the most perfect, most exquisite, most improbable order imaginable. This is the true miracle of our cosmos. Not that it is becoming more disordered, but that it had so much order to begin with. Let us try to picture it. Not as an explosion, for that word conjures images of chaos and violence, of shrapnel flying in all directions. That is an image of entropy increasing. No, let's imagine something far quieter, far more profound. Imagine a cosmic music box. Before the beginning of time, this music box is wound to its absolute limit. Every gear, every spring, every pin on its rotating drum is held in a state of perfect, silent tension. It is a single, unified object of pure potential. All the music of the future, every symphony, every lullaby, every star's hum, and every galaxy's silent spine is encoded in that tension. But for now, there is only stillness. A silence so profound it is not the absence of sound, but the presence of all sound, held in perfect balance. This is the state of the universe before its first moment. A state of breathtakingly low entropy. A single, perfect, wound-up configuration. Then something happens. The catch is released, and the music box begins to play. The first tick is the Big Bang. It is not a chaotic shattering. It is the beginning of an unwinding, a slow, graceful, and perfectly orchestrated release of that primordial tension. In its first moments, the universe was unfathomably hot and dense, a seething plasma of energy and fundamental particles. And it is easy to mistake this image for one of chaos. But in the language of entropy, it was a state of sublime order. Why? Because it was incredibly smooth. Imagine a fog so uniform that every droplet is perfectly spaced from its neighbors. Imagine a canvas painted a single, flawless, uniform color, with no brushstrokes, no variations. This was the early universe. The energy and matter within it were distributed with a smoothness that defies comprehension. It was almost perfectly the same in every direction you looked. There were no structures, no galaxies, no stars, no planets, no people, no intricate castles of sand, just the smooth, uniform beach waiting. This stunning simplicity, this uniformity was its order. It was a low-entropy state because there are very few ways for something to be that perfectly smooth, just as there is only one way for a deck of cards to be in perfect new-deck order. The universe we see today, with its vast tapestries of galaxies and its empty, silent voids, is far lumpier, far more complex. There are countless ways to arrange the matter and energy into the lumpy state we see now. Therefore, our universe today has a much higher entropy than it did at its dawn. The arrow of time is the melody playing as the music box of the cosmos unwinds from its simple, smooth beginning into its complex, lumpy present. So what caused the lumps? What coaxed the structures into being? It was gravity. Gravity, the patient sculptor of the cosmos. In that almost perfect smoothness of the early universe, there were tiny quantum fluctuations. Variations in density so infinitesimally small they were like a single grain of sand being a fraction of a millimeter higher than its neighbor on an otherwise perfect beach. And gravity, patient and persistent, went to work on these tiny imperfections. Wherever there was a slightly denser region, gravity's pull was a tiny bit stronger. It gently coaxed more matter and energy towards it. And as more matter gathered, its gravitational pull grew, pulling in yet more matter. It was a slow, snowballing effect over hundreds of millions of years. This is not an act of creating order. It is the opposite. Think of it this way. A perfectly smooth distribution of gas in a room is a low-entropy state. If gravity could pull all that gas into a single, tight ball in the corner, releasing heat and energy in the process, the overall entropy of the room would have increased. You have created a pocket of order, the ball of gas, but at the cost of creating a much, much greater amount of disorder in the form of waste heat radiated throughout the rest of the room. And that is exactly what stars are. They are the magnificent consequences of gravity's work. As gravity pulled vast clouds of primordial hydrogen and helium together, the pressure and temperature at their cores grew immense, until they ignited in nuclear fire. A star is born, and in that moment, a tremendous engine of entropy is switched on. A star takes beautifully ordered matter-simple atoms and, through fusion, forges them into more complex elements. But in doing so, it releases a colossal amount of disordered energy in the form of heat and light. This light, this radiation, streams out into the cold, empty void of space, spreading out, warming the universe, and massively increasing its overall entropy. Every star you see in the night sky is a beautiful bonfire, taking the ordered fuel of the early universe and turning it into the disordered ash and light of the present. And galaxies are simply vast cities of these bonfires. So, the arrow of time, the reason your teacup cools and eggs break, is written into the very initial conditions of our universe. It is because the universe was given a gift at its birth, a state of incredibly low entropy. It was handed a perfectly wound music box. It was set up with a vast potential to change, to evolve, to happen. Without this initial low-entropy state, nothing could ever have unfolded. If the universe had been born in a state of high entropy, a state of perfect equilibrium, with everything already spread out and uniform and cold, it would have been the end of the story at the very beginning. It would be like starting with a cup of lukewarm tea. Nothing happens. Time would have no direction, because there would be no lower entropy state in the past to distinguish it from the future. We exist, you and I, because the clock was wound. We are living in the melody. Every thought in your head, every beat of your heart, every memory you hold, is a part of this grand, cosmic unwinding. We are the complex, intricate patterns that are possible only because the universe began in a state of profound, beautiful simplicity. So, as you rest here, feel the echoes of that beginning. Feel the unwinding in the gentle rhythm of your own breath. You are not separate from this process. You are a living, breathing, thinking part of the universe's long, slow, and magnificent journey from its perfect, silent, tension-filled past toward its vast, quiet, and peaceful future. The music is still playing. Section 4: Why We Remember the Past. Let us drift back now, from the cosmic dawn to the intimate landscape of your own mind. We have seen how the universe unwinds, how stars burn, and how the great river of entropy flows ever onward. But how does this grand, cosmic principle touch the most personal thing we know, our own consciousness, our sense of the passage of time? Why is it that you can remember the soft light of this morning, but you cannot remember the sunrise of tomorrow? The answer is woven into the very fabric of entropy. Memory, in its most fundamental form, is an ordered record of a less ordered world. Your brain, a miraculously complex structure, creates a small pocket of Ordera memory trace that corresponds to an event that has passed. It's like finding a single, intact seashell on a beach that has been smoothed by the tide. The seashell is a record, a small, ordered remnant of a creature that once lived. Tells a story of the past. It does not, and cannot, tell a story of a creature that has yet to exist. Think about making a footprint in the sand. You press your foot down, creating an ordered, intricate pattern. This footprint is a record of your presence. It's a low-entropy mark on a higher-entropy surface. The wind and the waves, agents of entropy, will eventually erase it, smoothing the sand back to its more probable, featureless state. But while it lasts, the footprint is a memory of the past. Can only be made by an event that has already occurred. You cannot leave a footprint of a step you have not yet taken. In the same way, your brain functions as a kind of entropic recording device. Every sight, every sound, Every feeling that comes into your awareness is a wave of energy and information from the outside world. To form a memory, your brain must perform an act of ordering. It must take this incoming flood of chaotic sensory data and arrange it into a stable, coherent pattern of neural connections. This process requires energy. It is, in a small, localized way, a fight against entropy. You are creating a small, intricate sandcastle of information inside your head. But to power this incredible act of ordering, your body must engage in a much larger act of creating disorder. You metabolize food breaking down complex, ordered molecules like sugars and fats into simpler, disordered waste products like carbon dioxide and water. The heat that radiates from your body as you lie here is a constant stream of high-entropy energy being released into the universe. The total entropy of you and your surroundings is always increasing, even as you create the tiny, ordered islands of memory within your mind. The universe always gets its due. To write a single line in the book of your memory, you must burn a page from the universe's book of order. This is why we remember the past and not the future. The past is where the causes are, and the future is where the effects lie. A cause is always a lower entropy state than its effect. The unbroken egg, low entropy, is the cause of the broken egg, high entropy. The hot cup of tea, low entropy, is the cause of the cool cup of tea and a slightly warmer room, high entropy. A memory is an effect, an imprint, left by a cause that has already happened. The arrow of time and the arrow of causality point in the same direction, and they are both guided by the relentless flow of entropy. Imagine you are watching a video of a diver jumping off a diving board and splashing into a pool. You see the diver on the board, an ordered state, then flying through the air, and then hitting the water, sending out a chaotic spray of droplets in every direction, a disordered state. The sequence makes perfect sense. The cause is clear, the effect follows. Now imagine watching that video in reverse. You see a chaotic splash of water spontaneously converging, launching a person backwards out of the pool, perfectly dry, to land gracefully on the end of the diving board. Feels wrong. Feels impossible. We instinctively know that the world doesn't work this way. Our sense of logic, of cause and effect, is fundamentally an intuitive understanding of the second law of thermodynamics. We know that coordinated, large-scale events, the converging splash, don't just happen without a cause. Time, for us, is the sequence that makes causal sense. And the sequence that makes causal sense is the one in which entropy increases. Our minds, therefore, are fundamentally oriented towards the past. We are historians of our own lives. We collect data, we form records, and we build a story of what has been. We cannot be historians of the future because the future has not yet left any footprints in the sand. The information from tomorrow has not yet reached us. It is still an unwritten page, a vast ocean of probabilities. The future is open, full of potential. There are countless ways the molecules in the air of your room could arrange themselves in the next second. There are countless paths your life could take tomorrow. This openness, this branching of possibilities, is a feature of high entropy. The past, however, is fixed. There was only one way that the egg broke. There was only one path the milk swirled in your tea. The past is a single, low-entropy path that has been walked. This asymmetry between a fixed past and an open future is the very essence of our experience of time. And it is entropy that draws the line between them. So when you lie here and let your mind drift through old memories, a childhood holiday, the face of a loved one, the taste of a favorite meal, you are accessing these ordered structures, these low-entropy imprints that your brain has fought to create and maintain. Each memory is a testament to the past's unique, ordered state. It is a whisper from a time when the universe was slightly less random than it is now. And what of our predictions, our plans, our hopes for the future? Are they not a kind of memory of what is to come? Not in the same way. Plan is not a record. Plan is a map. It is an attempt to impose order on the probable chaos of the future. It is you, standing on the beach, drawing a blueprint for a sandcastle you hope to build tomorrow. You are anticipating the flow of entropy and trying to work with it, or against it, to achieve a desired outcome. But the map is not the territory. The future retains its freedom, its high-entropy openness, and it may or may not conform to your plans. Let this thought bring you a sense of peace. The past is behind you, recorded in the ever-increasing entropy of the cosmos. It is fixed and cannot be changed, and your memories are the precious, ordered fossils of that journey. The future is an open sea of possibility, not yet written, and you exist in the beautiful, fleeting moment of the present, where the high-entropy chaos of the future is continuously crystallizing into the low-entropy record of the past. You are the pen, and your life is the ink, and the story is written only in one direction, one moment at a time. Section 5. Life, the exquisite temporary rebellion. As we drift on this cosmic river, we have come to see the universe as a grand story of unwinding, a gentle cascade from order into a peaceful, simple freedom. We have seen that the arrow of time is the narrator of this story, always telling it from beginning to end. But look around. Look at the intricate veins of a leaf. Think of the complex architecture of a nautilus shell. Consider the breathtaking, organized miracle that is your own body. Life, in all its wondrous forms, seems to be a direct contradiction to this cosmic trend. While the universe as a whole sighs into a state of higher entropy, life builds things. It organizes. It creates pockets of the most astonishingly low entropy, the most intricate and improbable order. A single living cell is a universe of complexity, a bustling city of molecular machines all working in perfect harmony. It is a sandcastle of such magnificent detail that it makes our imaginary one on the beach look like a simple mound. Life is the universe's beautiful, temporary rebellion. It is a rebellion, but it is not a violation of the rules. Life does not break the second law of thermodynamics. It is, in fact, the most ingenious and masterful exploiter of it. Life is a process that has learned to surf the wave of entropy. It carves out its space of incredible order, but it does so by creating an even greater amount of disorder in its surroundings. Let's return to our image of the sandcastle. Imagine you are not just building one castle, but you are a tireless, driven builder, constructing an entire city of sand. To do this, you would need a tremendous amount of energy. You would be running all over the beach, kicking up sand, breathing heavily, your body burning fuel and radiating heat. While your sand city becomes more and more ordered, the beach around you, the air, and your own body's energy stores become more and more disordered. The net result is still a massive increase in total entropy. You have simply channeled the flow of energy to create a temporary local masterpiece of order. This is precisely what life does. Think of a simple plant. It sits in the sunlight, a quiet, green miracle. It takes in sunlight, which is a form of low entropy, high-quality energy from the star engine we spoke of earlier. It takes in simple, disordered molecules like carbon dioxide from the air and water from the soil, and through the magic of photosynthesis, it weaves them together into complex, highly ordered sugar molecules. It builds intricate structures of cellulose to form leaves and stems, creates a stunning pocket of order. But to do this, it must obey the cosmic law. The process of photosynthesis is not perfectly efficient. As the plant captures the sun's high-quality light, it re-radiates a great deal of low-quality, high-entropy energy back into the environment in the form of heat. The order it creates in its own body is purchased at the cost of a much larger payment of disorder to the universe. The books are always balanced. The universe always gets its share. And you, as you lie here, are doing the same. You are a warm-blooded creature, a furnace of incredible complexity. You maintain a constant body temperature, a highly ordered state, in an environment that is often cooler. To do this, you consume ordered fuel food. Food is just the stored solar energy captured by plants, or by animals that ate plants. You take these complex, ordered molecules and you break them down in the process of metabolism. This process powers everything you do, from the beating of your heart, to the firing of your neurons, to the simple act of breathing. And with every breath you exhale, you release disordered carbon dioxide. With every calorie you burn, you radiate disordered heat into your surroundings. You are a whirlpool of order in the river of entropy. You are constantly pulling in ordered matter and energy, using it to maintain and build your own intricate structure, and then expelling a far greater amount of disordered waste and energy back into the river. Life, then, is not a defiance of entropy. It is the ultimate expression of it. Life is the universe's most effective tool for creating entropy. An inert rock sitting in the sun will warm up and radiate heat, increasing entropy. But a living tree in that same spot will run the complex machinery of photosynthesis and respiration, acting as a far more efficient engine for degrading the sun's high-quality energy into low-quality heat. A dead planet is a simple system. A living planet, with its complex biosphere, its food webs, its cycles of birth, growth, and decay, is a vastly superior entropy-generating machine. This perspective can change the way we see the world. It frames life not as a fragile fluke in a hostile universe, but as a natural, perhaps even inevitable consequence of the laws of physics. Wherever there is a steep enough gradient of energy like the hot sun and cold space, the universe will find clever ways to break down that gradient. And life is the cleverest way of all. Think of the cycle of life and death. A seed grows into a magnificent, ordered tree. For 100 years, it stands as a bastion of low entropy. But eventually it falls. And then, an army of decomposers, fungi, bacteria, insects goes to work. They diligently break down the complex, ordered wood, returning its nutrients to the soil in a simpler, more disordered form. They are the universe's patient recyclers, ensuring that the temporary rebellion of order eventually rejoins the mainstream flow. The story of every living thing is the story of a temporary sandcastle, built with great effort, that is eventually, gently, and necessarily washed back into the sea. And this is not a tragedy. It is the condition that makes it all possible. The flow of entropy, the constant process of things breaking down, is what provides the raw materials for new things to be built. The decay of an old forest fertilizes the soil for a new one. The food you ate today was once a living thing, and by breaking it down, you gain the energy to continue your own brief, beautiful existence. So feel your own life force, the gentle warmth of your skin, the steady rhythm of your breath. Recognize it for what it is: a fleeting, exquisite, and perfectly natural eddy in the great cosmic river. You are a temporary pattern, a brief song played on the unwinding music box of the cosmos. You are made of stardust that has, for a little while, learned to think. You are a part of the universe that has organized itself to be able to look back out at the rest of the universe in wonder. This is the gift of being a part of life's rebellion. It is temporary, yes, but while it lasts, it is the most beautiful thing in the known universe. Section 6. Stars, the great engines of change. Let us now lift our gaze from the intricate rebellion of life on our small planet and look outward, into the deep, dark velvet of the night sky. Pinned against that blackness are the stars. We see them as tiny, peaceful points of light, as serene and eternal beacons. But this stillness is an illusion born of immense distance. In truth, each star is a raging, colossal furnace, a magnificent engine whose sole purpose is to drive the cosmic dance of entropy forward. The stars are the heart of the universe's story of change. They are the great agents that take the simple, pristine order of the early cosmos and transform it into the rich, complex, and ultimately more disordered universe we inhabit today. Without stars, the arrow of time would still point forward, but the journey would be infinitely slower, quieter, and perhaps far less interesting. Let's travel in our minds toward one of these distant suns. As we get closer, the peaceful point of light resolves into a terrifying, beautiful sphere of incandescent plasma, a continuous explosion held in check by its own immense gravity. We spoke of how gravity, the patient sculptor, pulled the smooth, primordial gas of the early universe into clumps. A star is what happens when one of these clumps becomes so large and so dense that the pressure at its core ignites a fire unlike any other, the fire of nuclear fusion. This is the star's secret. It takes the most ordered form of matter left over from the Big Bang, simple hydrogen atoms, each just a single proton and a single electron. This is the universe's most basic, low-entropy fuel. In the crushing inferno of the star's core, these hydrogen atoms are slammed together with such force that they overcome their natural repulsion and fuse, forming new, heavier elements, starting with helium. This act of creation, of forging new elements, might seem like an act of ordering. And in a very small way it is. You are creating more complex atomic nuclei. But this small act of local ordering is paid for with an astronomical price in disorder. The process of fusion releases a tremendous amount of energy, as dictated by Einstein's famous equation, E equals mc squared. A tiny amount of mass is converted into a colossal flood of energy. And this energy, in the form of high-energy photons, particles of light and neutrinos, erupts from the core. This flood of energy is pure, high-grade chaos. It is the star's entropy payment to the universe. These photons begin a long, random journey out of the star, taking thousands, even millions of years to stagger their way from the core to the surface, being absorbed and re-emitted countless times in a chaotic dance. When they finally break free from the star's surface, they stream out into the cold, empty void of space as light and heat. This is the starlight we see. It is the magnificent, disordered exhaust of a cosmic engine. It travels for years, for millennia, for eons, spreading out, becoming ever more diffuse, ever more disordered, carrying the star's entropy contribution across the galaxy. It is this light that warms distant planets. It is this light that provides the low-entropy energy source for life to begin its own beautiful rebellion. Your own existence is powered by the entropic exhaust of our sun, a star 93 million miles away. You are, quite literally, living on borrowed chaos. A star's life is a constant, epic battle between two fundamental forces. Gravity, the great organizer, is always trying to crush the star, to pull it all inward into an ever-denser ball. The nuclear fusion in the core, the great disorganizer, is always pushing outward, releasing a torrent of energy that resists gravity's embrace. For most of a star's life, these two forces are in a beautiful, stable equilibrium. The star hums along, a steady engine, for billions of years, converting its ordered fuel into disordered light. But eventually, the fuel begins to run out. A star like our sun will eventually exhaust the hydrogen in its core. When this happens, the outward push of fusion weakens, and gravity begins to win. The core contracts and heats up even further, until it becomes hot enough to ignite the next element in the sequence, helium. The star then begins fusing helium into heavier elements like carbon and oxygen. This process continues, with the star forging heavier and heavier elements in its core: carbon, neon, oxygen, silicon. Each stage of burning is a new, more desperate attempt to hold back the inevitable crush of gravity. And each stage releases energy, continuing to flood the cosmos with entropy. The star, in its later life, becomes a cosmic onion, with a core of the heaviest elements surrounded by shells where lighter elements are still burning. For smaller stars like our Sun, this is near the end of the line. They will eventually shed their outer layers as a beautiful, glowing cloud called a planetary nebula, final, gentle puff of disordered gas and dust back into the cosmos. The hot, dense core that remains, a white dwarf, is like a cosmic ember. It has no more fuel to burn. It is a ball of incredibly dense, ordered matter that will simply cool and fade over trillions of years, its final entropy payment made in the form of slowly radiating away its last remnant of heat. But for stars much more massive than our Sun, the ending is far more spectacular. They continue fusing elements all the way up to iron. Iron is the ultimate cosmic ash. Fusing iron does not release energy. It consumes it. So when a massive star's core becomes solid iron, its engine suddenly, catastrophically, switches off. In an instant, gravity wins. The star's core collapses in on itself with unbelievable violence. The outer layers of the star, now unsupported, come crashing down, then rebound off the impossibly dense core in a titanic explosion we call a supernova. A supernova is one of the most violent and most important events in the universe. In that single brilliant flash which can outshine an entire galaxy, the star blasts all the heavy elements it has forged throughout its life out into space. It is in the unimaginable heat and pressure of the supernova itself that the heaviest elements of all gold, silver, platinum, uranium are created. Every atom in your body that is heavier than hydrogen and helium was forged in the heart of a star that lived and died long ago. The iron in your blood, the calcium in your bones, the oxygen you breathe, you are made of stardust. You are built from the ashes of these great cosmic engines. The supernova is the star's final, glorious act of entropy. It takes its own ordered structure and blasts it into a vast, expanding, chaotic cloud of gas and dust, enriching the universe with the building blocks for new stars, new planets, and new life. So when you look up at the stars tonight, see them for what they are. They are not just peaceful lights. They are the great furnaces of change, the engines that drive the universe forward on its one-way journey. They are the reason we have complexity, the reason we have chemistry, the reason we have life. They are the ultimate servants of entropy, sacrificing their own order so that the universe can become a richer, more interesting, and more beautifully disordered place. Section 7. Black Holes. Entropy's Silent Thrones. We have lingered in the brilliant, explosive death of a massive star, watching it seed the cosmos with the elements of life. But we must ask, what becomes of the heart that endures? What is the fate of the core that collapses under gravity's final, unconquerable victory? The answer is the most enigmatic and profound object in the entire universe. When the remnant of a truly giant star is massive enough, gravity's crush does not stop. It does not find a new equilibrium. It continues, compressing matter past every known limit, squeezing it down beyond the state of a white dwarf, beyond even the density of a neutron star, until it collapses into a single point of infinite density, a singularity. And around this impossible point, a wound opens in the fabric of spacetime itself. We call this a black hole. Let us not think of it as a hole in the way we imagine a hole in the ground. It is not empty. It is, in fact, the most full object imaginable, an immense amount of matter packed into an infinitesimal space. It is better to imagine it as a well, a gravity well so deep and so steep that nothing, not even light, the fastest thing in the universe, can climb out once it has fallen in. Let your mind travel now, across the star-strewn void, to the edge of one of these cosmic enigmas. From a safe distance, it appears as a sphere of perfect blackness, a hole punched in the tapestry of stars behind it. It does not glow, it does not shine. It only takes, This edge, this boundary of perfect black, is not a physical surface. You could pass through it without feeling a thing. It is a threshold. Scientists call it the event horizon. It is the point of no return. The event horizon is the ultimate one-way membrane. It is the arrow of time made manifest in space. Things can fall in, but nothing can ever come out. It is a door that only opens inward. In a universe governed by the increasing flow of entropy, the event horizon of a black hole is perhaps the most perfect and ruthless expression of that law. It is the final destination from which there is no retreat, no reversal. The egg cannot be unbroken. The diver cannot fly back out of the pool. And nothing can escape the gravity well of a black hole. For decades, this posed a profound puzzle for physicists, a paradox that touched the very heart of entropy. If entropy is a measure of disorder, of hidden information, then what happens to the entropy of the things that a black hole swallows? Imagine a hot star, a complex and highly entropic object, collapsing into a black hole. Or imagine a cup of hot tea, with all its chaotic, swirling molecules, being dropped into one. From the outside, the black hole that remains seems incredibly simple. It can be described by just three properties: its mass, its spin, and its electric charge. It has no temperature, no texture, no memory of what it ate. It seems to have erased all the complex information, all the intricate disorder of the things it consumed. It looks like a perfectly ordered, low-entropy object. This would be a violation of the second law of thermodynamics. It would be like watching the broken pieces of an egg spontaneously gather themselves up and vanish, leaving a perfectly clean floor. It would mean that the total entropy of the universe could decrease. For a long time, black holes seemed to be cosmic criminals, cheating the most fundamental law of reality. The solution came from a brilliant insight, a marriage of quantum mechanics and relativity. The entropy is not gone. It has simply been hidden from us. The entropy of a black hole is not measured by its simple exterior, but by the vast amount of information that is locked away forever inside it, beyond the veil of the event horizon. And here is the most poetic part of the discovery. The entropy of a black hole, the measure of all the lost stories and hidden states within it, is proportional to the surface area of its event horizon. Think about that. It is not proportional to the volume of the black hole, as you might expect. It is written on the surface. The event horizon itself is like a cosmic ledger, a vast, silent record book. And as more matter and energy fall in a star, a planet, a cloud of gas, the black hole's mass increases, and its event horizon grows. The surface area gets bigger, and in doing so, it creates more page space to record the entropy of what it just consumed. The ledger expands to accommodate the new entry. From this perspective, black holes are transformed. They are not the destroyers of entropy. They are its greatest champions. A single, large black hole can contain more entropy than all the stars and galaxies in the visible universe combined. They are the universe's ultimate storage devices for disorder. They are entropy's silent thrones. Here, in the absolute quiet of spacetime, entropy reigns as an absolute monarch. All the complex stories of the matter that falls in the intricate dance of atoms in a star, the billion-year history of a planet, the fleeting thoughts of a living being are subsumed into the black hole's single, unified state. All that information is not destroyed, but it is rendered inaccessible, hidden behind the one-way door. The black hole's entropy is a measure of our profound and permanent ignorance about what lies within. It is the final, perfect shuffled deck of cards, from which no hand will ever be dealt again. And yet, the story has one last, whispered twist. Stephen Hawking discovered that even these silent thrones are not eternal. Due to subtle quantum effects at the very edge of the event horizon, black holes are not perfectly black. They should over unimaginable timescales, radiate a faint, cold glow. This is now known as Hawking radiation. It is a slow, patient process, a gentle leak. The black hole is molecule by molecule, sighing its stored information back out into the universe. For a black hole the mass of a star, this process of evaporation would take longer than the current age of the universe by many, many orders of magnitude. But it is happening. Even entropy's great monarch must eventually abdicate. And so, in the far, far distant future, in the long twilight of the cosmos, the black holes themselves will slowly, gracefully, evaporate away in a final whisper-soft puff of low-energy radiation, returning their immense store of entropy back to the universe. It is the final unwinding, the last note of the cosmic music box, fading into an eternal, peaceful silence. For now, they sit in the darkness, these silent monuments to time's arrow. They are not monsters. They are a natural and necessary part of the cosmic ecosystem. They are the quiet rulers of the inevitable, the physical embodiment of the universe's long, slow journey toward its most probable, most peaceful, and most simple state. Section 8. The Mystery of Lost Information. We have journeyed to the edge of entropy's silent throne, the black hole, and witnessed its quiet, patient reign. We have seen how it gathers all things into its deep embrace, its event horizon growing like a ledger to record the entropy of a swallowed star or a forgotten world. And then we heard a final whisper, the faint, ethereal glow of Hawking radiation, a sign that even these bastions of permanence will, over eons, dissolve back into the cosmos. This final, gentle sigh of the black hole brings us to one of the most delicate and profound questions in all of science. It is a question that sounds more like poetry than physics, a riddle that touches the very nature of existence, memory, and time. What happens to the stories? What happens to the information that falls into a black hole? When we speak of information here, we mean something more fundamental than just the words in a book or the memories in a mind. In physics, information is the precise, unique state of every particle. It is the exact position, momentum, and quantum properties of every atom in your teacup. It is the intricate, specific pattern of neurons that formed the memory of your first love. It is the complete blueprint of an object, containing all the details that make it what it is and not something else. A core principle of our understanding of the universe, a law as sacred as any other, is that this fundamental information can never, ever be truly destroyed, can be scrambled, can be rearranged. It can be hidden so well that it is, for all practical purposes, lost to us. But it cannot be erased from existence. Imagine you write a secret message on a piece of paper and then burn it. The message is gone. The paper is ash. It seems as though the information has been destroyed. But a physicist would tell you it has not. The information of your message is now encoded in the fantastically complex arrangement of the smoke particles, in the specific chemical composition of the ash, in the pattern of heat that radiated into the room. If you could, in principle, capture every single particle and trace its path, you could reconstruct the original message. The story isn't gone. It's just been translated into a language of chaos that is almost impossible for us to read. This is the universe we thought we lived in, a universe that, at its most fundamental level, remembers everything. But the black hole presents a challenge to this comforting idea. When the teacup falls into a black hole, its information, the specific dance of its atoms, is pulled behind the event horizon, a veil from which nothing can return. The information is hidden from us, but we believe it is still safely stored inside. The universe's ledger is balanced. But then the black hole begins to evaporate. It leaks Hawking radiation back out into space. And for a long time, it was believed that this radiation was completely random, completely thermal. It was thought to be a featureless, content-free hiss of energy. It contained information about the black hole's mass and temperature, but it held no trace of the unique, specific things that had formed it. It did not know about the teacup. It did not remember the star. And so we arrive at the paradox. The black hole slowly disappears, radiating away its mass. And when it is completely gone, when the final puff of radiation has faded into the void, what has happened to the information it held inside? If the radiation is truly random, then the information, the blueprint of the teacup, the story of the star has been utterly and completely erased from the universe. It is not just scrambled, it is gone. This is the black hole information paradox. It creates a gentle but profound tremor at the very foundations of physics. It suggests that our universe might have a flaw in its memory. It suggests that the past, in the most absolute sense, can be deleted. This is not a violent crisis, but a quiet, cosmic koan, a riddle the universe has whispered to us. Scientists have wrestled with it for decades, and the search for an answer has led to some of the most beautiful and mind-bending ideas ever conceived. One idea is that we were wrong about the radiation. Perhaps the gentle glow of a dying black hole is not random at all. Perhaps, if we could read it with unimaginable precision, we would find that the teacup story is still there, subtly encoded in the faint correlations between the escaping particles. The information would leak back out, not as a clear message, but as a fantastically complex and scrambled whisper, woven into the fabric of the radiation. The universe, in its final act, gives back the memories it borrowed, though they may be almost unrecognizable. The burned book story is, after all, hidden in the smoke. Another possibility is that the black hole never truly disappears. Perhaps the evaporation stops when it reaches a tiny, microscopic size, leaving behind a stable remnant, an indestructible little nugget of space-time. This Planck nugget would be a final, tiny library containing all the information of everything the black hole ever swallowed, a cosmic time capsule floating forever in the dark. And then there is perhaps the most wondrous idea of all, the holographic principle. It suggests that the information about a volume of space is not stored inside the volume itself, but is instead encoded on its boundary surface. Think of a hologram, a flat, two-dimensional film that can project a full, three-dimensional image. The holographic principle suggests that the universe might work the same way. All the information about the three-dimensional interior of the black hole, the star, the teacup, all their intricate stories might be fully and completely encoded on the two-dimensional surface of its event horizon. It is a ghostly and beautiful image. The event horizon is not just a point of no return, but a shimmering, holographic plate containing a complete record of everything lost within. And as the black hole evaporates, this information on the surface might be imprinted onto the outgoing radiation, allowing the stories to escape. We do not yet know the solution to this gentle mystery. It lies somewhere in the future, in a theory that can finally unite the grand, cosmic scale of gravity with the strange, uncertain rules of the quantum world. But for now, let the question itself bring you a sense of wonder. The universe is not a simple machine whose workings we have fully mapped. It is still a place of deep and enchanting secrets. The fact that we can even ask such a question, whether the cosmos has a perfect memory, is a testament to the power of our own fleeting, organized consciousness. Perhaps the stories are never truly lost. Perhaps they are just translated into a grander language, the language of spacetime, of quantum fields, of entropy itself. Your own story, the information that is uniquely you, is woven into this cosmic fabric. Every action, every breath, every thought contributes to the state of the universe. And perhaps, in a way we cannot yet comprehend, the universe does not forget. It simply rearranges the words, and continues telling its magnificent, unending story. Section 9. The long, quiet twilight of everything. Having lingered at the edge of the universe's greatest mystery, let us gently pull back our focus. Let us zoom out from the single, enigmatic fate of a lost story and instead cast our gaze down the longest river of all, the river of deep time, following the current of entropy not just to tomorrow or to the end of a star, but to its ultimate, final destination. We are going on a journey to the end of time itself. There is no hurry. The timescales we are about to witness are so vast that our human lives, and even the entire history of our planet, are less than a single heartbeat in comparison. So let your mind relax, and let it drift into the deep, deep future. We begin in what is known as the stelliferous era, the age of stars. This is the era we live in now. It is a bright, busy, and vibrant time for the cosmos. The universe is filled with the great engines of entropy, the stellar furnaces burning their hydrogen fuel and bathing galaxies in light and warmth. New stars are still being born from vast clouds of gas and dust, and life has found a way to flourish on at least one small, rocky planet. But this brilliant age is fleeting. It is the universe's vibrant youth, and it cannot last. Let us fast forward. One by one, over trillions of years, the bonfires will go out. The great, massive blue stars were the first to go, living fast and dying young in spectacular supernova explosions. The smaller, more patient stars, like our own sun, will burn for billions of years before puffing away their substance and leaving behind their cooling, white dwarf embers. The last lights to fade will be the smallest, dimmest, and most frugal of all, the red dwarfs. They sip their fuel so slowly that they can live for trillions of years. But even they are finite. Imagine a sky trillions of years from now. The familiar constellations are gone. The Milky Way is a dark, invisible river. The only lights are the last, fading, ruby-red embers of these dying stars. Then, one by one, over a span of time our minds can barely encompass, they too will flicker and die. The last star in the universe will go out, and an immense silence will fall. The stelliferous era is over. The age of stars has given way to the degenerate era. The universe is now a vast, cold, and almost completely dark graveyard. It is populated only by the corpses of stars. Cold brown dwarfs, dead neutron stars, and the fading black dwarfs that were once suns. And, of course, the silent rulers of this age, the black holes. For a time, it seems as if nothing is happening. The universe is a static realm of ghosts. But entropy's work is never truly done. It is just becoming more patient. On timescales that make the lifetime of a star seem like the blink of an eye, a new, subtle process of decay may begin. This is a deep and hypothetical idea, but a beautiful one. It is the concept of proton decay. It suggests that the very building blocks of matter that we consider eternal, the protons and neutrons in the heart of atoms, are not truly stable. They too have a lifespan, albeit one that is almost incomprehensibly long. After perhaps 1,000 trillion years, a single proton sitting silently in the heart of a dead star may spontaneously unravel, dissolving in a tiny, final flash of energy. Imagine this process. Across the vast, dark expanse, a single dead star, a diamond-like sphere of crystallized carbon, has been floating in the cold for eons. And then a single atom within it gives up its form. A faint, lonely spark of light flickers and vanishes. 1 trillion years later, it happens again. It is the slowest, most patient decay imaginable. It is the universe gently unmaking itself, atom by atom. It is the sandcastle of matter itself, built in the fires of the Big Bang, and stars, slowly, grain by grain, dissolving back into the featureless beach of pure energy. Over countless googolls of years, this slow decay will claim everything. All the dead stars, all the frozen planets, all the scattered dust will evaporate into a thin, cold mist of radiation and elementary particles. The universe will have dismantled all of its structures. And what will be left reigning over this profound emptiness? Only the black holes. This is the black hole era. For a stretch of time even more immense than the age of proton decay, these silent thrones of gravity will be the only organized things left in the cosmos. They will float in the darkness, having swallowed the last of the galaxies, the last of the dead stars. They will hold within them the final, scrambled stories of everything that ever was. But as we have learned, even they are not eternal. The faint whisper of Hawking radiation continues. Over a span of years so large it is called a googol, one followed by 100 the stellar mass black holes will evaporate. The supermassive black holes at the hearts of what were once galaxies will take far longer, perhaps 1,000 trillion googolls of years. But they too will shrink, sighing away their mass, their energy, their impossibly vast stores of entropy back into the universe. Let your mind float in this final age. Picture the last black hole in the universe. It has reigned in the darkness for an unimaginable eternity. It is the final repository of all cosmic memory, the last complex object in existence. And it is now no bigger than an atom, radiating away its last few particles in a final, quiet puff of warmth. And then it is gone. And what is left? The dark era, the heat death of the universe. This is entropy's final victory. It is the state of maximum entropy, the ultimate equilibrium. Do not picture this as a terrifying void. Picture it as a state of perfect, unshakable peace. The universe is now a vast, limitless ocean of low-energy photons, neutrinos, and other fundamental particles all spread out in a thin, uniform, and incredibly cold soup. Everything is the same temperature, just a fraction of a degree above absolute zero. There are no structures. There are no hot spots and no cold spots. There are no stars to warm you, but no empty space to freeze you. Everything is one. And in this state of perfect, tranquil equilibrium, the arrow of time dissolves. Time itself ceases to have meaning. If every point in space is the same and every moment is the same, there is no longer a past that was more ordered and no future that can be any different. The cosmic music box has finished its song. The great river of time has slowed, widened, and emptied into a silent, boundless ocean. Nothing happens forever. This is the ultimate fate of the cosmic dance of entropy. A journey from a single, hot, dense, and perfectly ordered point to a vast, cold, diffuse, and perfectly disordered expanse. A final, gentle, cosmic exhalation. And a peace that passes all understanding. Section 10. The beauty of the fleeting now. We have journeyed to the end of all things. We have floated in the silent, timeless ocean of the universe's final peace. And now I want you to come back. Gently let your awareness drift away from that far, distant shore. Pull your mind back from the unimaginable eons, back through the age of black holes, back through the twilight of the fading stars. Feel your consciousness travel backward through the long night of the degenerate era until you see the lights come on again. You are back in the brilliant, busy, stelliferous era. You are back in the vibrant, youthful, and chaotic present. You are back here. Now. After witnessing the long, slow, and inevitable unwinding of the cosmos, it is easy to feel a sense of insignificance. A feeling that our lives, our struggles, our joys, are just a momentary flicker in an immense and indifferent darkness. But I invite you to see it from another perspective. I invite you to see that it is the very fleetingness of this moment that gives it its profound and breathtaking beauty. The universe is only interesting because it has not yet reached its final state of peace. It is only in this brief, intermediate stage, this era of stars and entropy in motion, that complexity, change, and life are possible. The final, tranquil equilibrium is a state where nothing happens. We are lucky enough to exist in the time of happening. Think of a magnificent wave rising from the surface of a calm ocean. It exists for only a moment. It swells, it crests in a brilliant spray of foam, and then it subsides back into the hole. The wave's beauty is not diminished by its brief existence. Its beauty is its brief existence. It is a temporary, exquisite form that the ocean has taken. It is the ocean's way of expressing itself for just a moment. You are that wave. Your life is that wave. Humanity, life itself, this entire, brilliant era of star sway are all a temporary, beautiful, and complex form that the universe has taken on its long journey from simple order to simple chaos. We are not a mistake. We are not an accident. We are a natural and glorious part of the process. We are the universe's way of creating intricate sandcastles, of swirling cream into the coffee, of thinking, feeling, and wondering about itself before the tide comes in and smooths the beach once more. The arrow of time, the relentless march of entropy, is not our enemy. It is the very thing that gives our lives meaning and direction. It is the river that allows us to have a journey at all. It is because of entropy that we can create, that we can learn, that we can love, and that we can remember. It is the force that turns a static photograph into a moving picture. The story of our lives can only be written because time moves forward. To love something is to accept that it is temporary. You do not stop admiring a flower because you know it will eventually wilt. The knowledge of its impermanence makes its current bloom all the more precious. You do not stop cherishing a warm, sunny day because you know the sun will eventually set. The setting of the sun is what gives the day its shape, its story. And so it is with our lives. Our existence is framed by a beginning and an end. This frame is not a prison. It is what gives our life its shape, its meaning, its preciousness. Every choice we make, every kindness we offer, every moment of wonder we experience, has value precisely because it happens now, in this brief window of possibility. We are here to witness the unfolding, to be a part of the dance. The knowledge that the universe is flowing towards a final, quiet state can bring a profound sense of peace to our own, smaller journeys. It reminds us that all things, even our deepest worries and our most pressing anxieties, are temporary patterns. They too are eddies in the river, and the current will eventually carry them along. There is a cosmic permission to let go, to release our grip on the things we cannot control, and to simply be present with the flow. You are a collection of stardust that has, for a little while, woken up. You are a part of the cosmos that has developed the ability to look up at the stars and feel awe. You are a channel through which the universe experiences its own majesty. This is not a small thing. It is a miracle, a beautiful, improbable, and temporary miracle. So as you lie here, on the cusp of sleep, feel the gentle rhythm of your own entropy. Feel the warmth of your body, a small, temporary star in the darkness of your room. Feel the ordered thoughts in your mind beginning to soften, to spread out, to drift into the free, disordered, and creative world of dreams. You are participating in the cosmic dance, even in your rest. You are letting go, just as the universe, in its own grand way, is always letting go. Do not fear the arrow of time. It is the artist's brush, the storyteller's pen, the musician's bow. It is what makes the music of existence possible. And you are a unique and unrepeatable note in that cosmic symphony. Find peace in your part of the song. Find beauty in the fleeting now. Now let these cosmic thoughts drift away like clouds. Let the vastness of space and time become a soft, comforting blanket around you. There is nothing left to solve, nothing left to understand. There is only the gentle, quiet rhythm of your own breathing, a small and perfect part of the universe's great, peaceful sigh. You are safe. You are at peace. And you are ready for a deep and restorative rest. Good night.